It's my pleasure to introduce the next two speakers. We're going to be talking about improving traffic safety through video analysis in Jakarta, Indonesia. Aniket Kesari is a JD student at Yale University and a PhD candidate in Jurisprudence and Social Policy at the University of California, Berkeley. He specializes in law and economics and law and data science. His main research interest is in information privacy and cybersecurity law, and also has ongoing projects dealing with digital consumer protection, smart cities, and trademark law. Also want to introduce Raesetje Sefala. Raesetje is a computer science master's student at Wits University in South Africa. Her research interests include applying machine learning to help solve problems experienced by countries in the developing world. Her master's work is about using satellite imagery and computer vision to study the effects and evolution of spatial apartheid in South Africa. And she is a recipient of the Data Science for Social Good Fellowship at the University of Chicago. Without further ado.
Thank you. All right, good afternoon, everybody. We're really excited to follow this last panel because this is a really great example, we think, of really applying AI to social good and what it takes to work with an organization and really embed yourself in a local context to do that. So as you can see, we worked on improving traffic safety through video analysis in Jakarta, Indonesia. And we're really excited to show you the results of a collaboration between three really fantastic organizations that were able to achieve exactly that. So first, Data Science for Social Good at the University of Chicago. That's where the two of us came from, along with our colleagues. It's a summer fellowship hosted by U Chicago. We were there this past summer, and it basically brings together graduate students across data sciences, so computer science, statistics, the social sciences, to partner with local governments, NGOs, and other organizations that are aiming to have a public policy or social policy impact. Our partners this summer were in the city of Jakarta. So as you can see, Jakarta Smart City is a new city agency that is dedicated to bringing data science and data-driven tools to various agencies throughout the city of Jakarta across fields such as transportation, health, education, and other areas of social policy. Pulse Labs Jakarta is a branch of United Nations Global Pulse, which is also an agency that deals with data analysis, data science, and other data-driven techniques and analysis to enable cities and states across the entire world to make better social policy decisions. So before we get into the technical aspects of what we did, I first wanted to pause and talk a little bit about what it takes to really frame a social problem like this and then tackle it with a technical solution. So, Jakarta is a city in transition. It has grown from a population of a little over 2 million in 1970 to over 10 million today, becoming the largest city in Southeast Asia. With that growth also comes a massive growth in the wealth of its citizens. And with that wealth comes more things like car ownership, motorcycle ownership. The city has grown and sprawled to a large size. And with more cars, and more sprawl comes more congestion and ultimately more traffic fatalities. The World Health Organization estimates that 1.25 million people die each year worldwide from traffic-related accidents. Over 2,000 of these deaths occur in the city of Jakarta, Indonesia alone. Understanding that, Jakarta took this opportunity to realize that if we could solve this problem in the city of Jakarta, we might be able to solve it all over the developing world, as this story of increased wealth, increased population, and increased traffic accidents has perpetuated throughout the entire world. So, at the start of the summer, we started by framing the problem in terms of what the actual safety risks were for the city of Jakarta. So I need to really stress this point, that anyone who wishes to do a similar kind of project, partner with a city, a government, anything like that, first, we had to spend weeks, and sometimes this could take months, even longer, before we touched any code, figuring out what the exact local problems were. So we asked the city to talk with us about what the safety risks were that they were most concerned about, and these are going to vary by local context. In Jakarta specifically, driving the wrong way against traffic was a big problem. Things like illegal parking, stopping, motorcycles sitting on sidewalks, things like this were issues specific to Jakarta that they were interested in solving. And again, if you were to do this elsewhere, you'd have to go through this process again and figure out what are the specific issues that are facing the city. At the same time, the city of Jakarta also has several policy levers available to it. And in the same vein, different cities, different governments are going to have different policy levers available to them. In Jakarta's case, in the medium term, they were interested in things like managing their traffic signals better, deploying traffic stewards or traffic cops, things like that, to particularly busy intersections to manage particularly intense or chaotic traffic. The issue with any kind of traffic and safety analysis, though, is that data is really hard to come by. The typical way that you might imagine somebody trying to gather data about traffic in a city is someone literally goes out to a street and starts counting the number of cars that go by with a clicker. That's not sustainable for a megacity the size of Jakarta, or indeed most cities that people live in. So, what Jakarta did have instead, though, is a massive amount of cameras posted throughout the city. Over 5,000, in fact, with many more to come. Basically, we saw ourselves as an intermediate step, where Jakarta has these certain safety risks, it has certain interventions it can apply, but it needs to know where it will be most effective with them. To do that, it needed this data. It didn't have this data, it instead had lots of video. This is a great start, but we had to figure out where can we go from this video to something that can really help policymakers make a difference. So this gives you a sample of what we started with, just raw video footage, completely unlabeled, but you can see there's a lot going on, lots of interesting stuff. You have traffic, you have people driving all sorts of ways, a multitude of different types of vehicles, so cars, motorcycles, bikes, tuk-tuks, minibuses, a range of things that make this a very interesting and real problem. So again, before we get into the technical solutions, I want us to think for a second about what it takes to go from a situation where we have video like this and what it would take to transform this into data that a policy analyst can then use to make a difference in their city. So imagine for a moment, if you will, hiring a technician to do this job. You might imagine hiring somebody, placing them in front of a video camera, and having them watch this intersection for a whole day, marking events of interest like whether someone drove the wrong way on the road, whether they stopped illegally, whether someone parked on the sidewalk, etc., etc. The problem is, this does not scale well at all. As I mentioned, there are over 5,000 cameras posted in Jakarta right now, with many more thousands to come. Once you start thinking about the human resources that would be necessary to watch these videos, it becomes intractable to be able to have so many people. We calculated it would require 44 million person hours each year just to watch the 5,000 cameras that we had that are currently available to Jakarta. Not only is this impractical, human beings are prone to make mistakes. It wouldn't even be feasible to expect them to do so accurately and consistently. We saw this as opportunity, however. Whereas human beings may not be great and it may not be scalable to have them watch all these videos, a computer maybe will do this at scale quite well. We figured that this is an opportunity to apply machine learning and other techniques in order to extract meaningful quantitative information and create a database that can ultimately inform city agencies and other policymakers as they attempt to design particular interventions for the city. So what does that look like? Basically, we had to go from raw video, basically pixels as far as a computer is concerned, to substantive meaning. So we're going to highlight for you 3 particular methods. First, detecting and classifying objects, so figuring out that this is indeed a car in this video frame. Second, get some sense of motion. This is a car that's moving. And third, get some sense of the context of a scene. What is a road? What is a sidewalk? When you put these pieces of information together, you suddenly get a sense of something like a car that is moving against traffic. So I'll turn it over to my colleague, Raesetje, to talk about these specific methods and how we did this. I'll leave it to that.
So firstly, sorry. So So firstly, we decided to use an object detection method in order to help us localize and classify objects. I mean, we were given video data with no labels. So this is just footage that comes from these intersections that my partner just described. So firstly, we decided to throw YOLO, the model, on it, and it actually performed surprisingly really well. So the problem, however, with using a model like YOLO, which was trained using data sets which are not actually localized to developing countries such as Jakarta, with minibuses and tuk-tuks and food carts on the road, is that you would also need to sort of fine-tune the model to include objects which are actually local to the context. So we also needed to understand whether or not the vehicles or the motorbikes that we actually detect and localize are actually moving or they're stationary. Well, this is really important given that in a place like Jakarta with huge, bad traffic jams, vehicles such as motorcycles usually move on the sidewalk. So we would literally need to understand whether the motorcycle which we detected is moving or stationary. Otherwise, if we would need to understand something such as cars which have illegally parked, which is really something which is common in an intersection like this, from the data we've seen, that a car would just park just next to you. See that black car over there? It would just park over there and then causing a traffic jam, perhaps taking someone out of the, waiting for someone to get out of the car. So we would need to understand whether or not it's moving. So we used optical flow, and how that actually was applied really well in this case was that for the objects which we have detected using YOLO and localized, we were able to just look at them and then check if they're actually moving or stationary. Finally, we applied a semantic segmentation model to sort of just get a sense of the scene, understand where the road is, where the sidewalk is, and where other things are actually, so that at the end we can actually say that a motorcycle is moving on the sidewalk. This is particularly really dangerous because it actually forces pedestrians to be on the road to make way for the motorcycles. So these are the methods we actually applied in order to help our partner actually reach the requirements which they were interested in. However, we had over 700 gigabytes of video data. So fairly high quality data as well. So we employed a more or less a streaming approach where we processed segments, 15-second segments of videos at a time through the pipeline. So we would actually allow the partner to decide whether or not they want to connect this pipeline to the live video cameras they have for near real-time kind of analysis, or perhaps for a more medium to long-term approach. They could just do this in the background and then look at the data collected later. So going back to the requirements our partner actually was interested in, imagine we are finding a motorcycle moving on the left side, which is against traffic as per our partner would have specified on the sidewalk. So this would then be flagged in the database as a violation. And if a car has stopped on the road, then this is illegal parking, which is a violation our partner might be interested in. So, this is in this scene. I don't know if you can notice the motorcycle moving against traffic. These are the kinds of problems our partner is actually interested in flagging in order to inform more medium to long-term goals of budgeting and planning on roads, where to deploy traffic officers, or how they can actually give evidence in order to request more budget in terms of getting more traffic stewards. So at the end, our solution looks something like this, where we can actually find problematic scenes like this. So these are all the cars which are moving against traffic. So that's the wrong lane, and then our model is actually able to flag these events. If you just, all the first three blocks, these are violations which happened on the same day within 2 hours. So the fourth one happened like 2 days later. But then this was just a sample from the data set we have. These are the sort of problems the city of Jakarta is facing and is actually interested in solving to help improve traffic safety in the long term. Thank you.
Thank you. Any questions?
We have one over here.
Hi, thank you. That was very interesting. I was wondering if you could use this kind of data to calculate the speed at which cars are moving, and if it's not only a way to deploy punishment for bad behavior, but also to facilitate maybe new planning of roads, putting that street in one way, or building a parking lot where people are stopping for no reason, something like that. Thank you.
That's actually a really interesting question. But when the problem we were actually dealing with in Jakarta had a lot to do with not only the problems with traffic, but also things like power outages. So you just get random power outages, and it's really difficult to get like sequential frames. Yeah, and so capturing data like that. But however, because of the traffic jam in Jakarta, it's really difficult to speed. So one of the first questions we asked our partner at the beginning was, what was the speed limit? And this was in a room full of like 12 people from Jakarta, and no one knew what the speed limit was. So.
To your second point, the thing I would add is that we want to clarify that this entire system is not meant to be punitive at all, and that actually took a lot of conversations with our partner to really clarify and like work out the ethics of what it is that we were doing. So ultimately what we delivered, it doesn't identify a particular vehicle, or it can't be used really to assign a fine to somebody by reading their license plate or something like that. We designed it, and the contract and the discussions with them all very much specified that this is being used to build a database which will be used to do exactly the sorts of interventions that you suggest. But really it's important to have these conversations throughout the entire process of developing this kind of project, because this is the sort of thing where we had to consider the ethics of what it is that we were doing and make sure that expectations were kind of clear on both sides as to what ultimately we wanted this system to be able to do.
Is it working? No? Yeah, I think it's working. I think you sort of started to answer my question. My question was about the ethical considerations that you have to make while working on a project like this. I've worked on similar projects that could be used for good things, but also inadvertently could be used for surveillance. My friend, he just texted me, be like, don't ask your student question, so, but I'm asking you. So yeah, just if you've thought about this.
Yeah. We have, the voice is against me.
No.
We have absolutely thought about this, and we've actually spent maybe half of the time in meetings just trying to sort of reiterate and just change our partners' mindset about potential users of a system like this. But then what a lot of things which we have actually realized in these kinds of conversations are that this particular partner, for example, who we were working with, it's almost like these are problems they haven't faced before. So it's like you're introducing a new technology, and then they'll be exploring, and then maybe someone will flag something about maybe ethics, and then debates, and then lawsuits, and things like that. They haven't actually went through that kind of process. So it was really important for us to actually walk them through the kind of implications which may arise from them asking us things like, can we actually track crowds and identify people? Can we take snapshots of scenes? So we had to have a lot of these conversations with them about that. They can't just do that and then try to explain and walk them through what privacy actually means for building systems which are meant for the public and which are actually meant for good.
Any more questions? Thank you.
Thank you.